Right, gentlemen, today we are starting with Unit 9, which is Quantitative Risk Analysis. Uh, in Quantitative Risk Analysis, naturally, we understand that we have already identified the risk and we have already done the qualitative analysis. Now, we just have sorted list of risks, which is a short-listed risks here, and we have to look at them for further analysis. Naturally, these sorted risks are actually going to tell us how much is the overall project risk to the project, and therefore I have to calculate it from that point of view. Now, there are two views. Number one, should we be calculating in detail each and every risk which has been shortlisted, or should we move ahead with an overall estimate of how much the impact of the risk would be on the whole project? Uh, I used to think that probably we have fewer risks left now, and they are shortlisted, and we probably can, if we have time, we probably can go down to the detail of each and every calculation of the exact amount of risk which is quantified, the exact amount of probability, and the amount at stake, as if I know exactly how much this risk will cause damage. Well, that could have been a very good approach, but we don't have that kind of time available here. For example, let's say if there is a likelihood of this room catching fire, uh, what is the probability of that? Let's first discuss the probability of this. Now, we are not talking about probability from a scale to 1 to 5 or in some assumed kind of percentage. Let us exactly calculate what percentage really is of this room catching fire. So, what is your opinion?
Sir, opinion on calculating the exact probabilities?
That this room can catch fire. So we have two things. One is the probability of room catching fire, and the second is the uh, amount at stake.
Impact.
The amount at stake. How much money will be lost? So first talking about probability. So what do you think? Wherever you're sitting, if this room catches fire, what is the probability of this room catching fire?
Sir, that is probably a numerical analysis being done upon similar kind of buildings. Means the
Mm,
data may be available to some municipal corporation or some organization like that,
got
or
it.
the firefighting department,
Okay.
and they might have calculated and estimated that house like this in the condition and the weather in such a weather means
Hmm.
what is the tendency and the probability, so we
Okay.
can have uh, access to the exact number from those departments or the areas who are the subject matter expert.
Okay. Can you tell me how much time will you take in ascertaining that, and how much money will be spent in getting this data? Effort and money.
So the probability, once we have the probability, then there would be an impact or like the money at stake.
No, no, no.
So
I'm not talking about that money. I'm talking about going to the fire department, collecting data from, the various sources, getting involved with them. You have to travel to them, you have to talk to them, you have to do telephone calls, you have to, burn some.
exactly, even wait on them. Exactly,
Yeah,
you're right.
exactly. So this will take a number of days, and you have a value. You are being invested for, say it is 10 days. You are as a person invested in that effort. For example, your salary is 30,000, then 10,000 is being spent on that as a person, and then you're also burning company oil and gas. So I mean to say that there is some effort required to put in to collect this data. It is just not
Sir,
for granted.
sir, if that has to be precise, so this is the way. Otherwise, means we can use heuristic, some
Yeah,
thumb
exactly.
rules.
But I just asked you, how can I get the most accurate data? Naturally, if the data is accurate, that would be the best option for me. But getting the best data, getting the most accurate data will cost money and time. And therefore,
Yes, the
I have to see what is the sensitivity of this risk, whether I should go into this much of effort or I should not, right? Uh, Mohit, probably there is some noise behind you. Okay, right. So, what I am saying is that although it is always ideal to have the accuracy of data, but the question again remains that should we invest this much money in collecting this data? Maybe you see, the similar kind of building structures. How many similar kind of building structures, and in what vicinity are we talking about? You may have to find out how many buildings of this sort is in this region of, say, whole of the city, and how many have caught fire in last 10 years, and things like that, and what were the causes of that. Again, how many fires were caused by what, and things like that. So this is actually going to give me the probability. And as far as the impact is concerned, okay, I'll get back to you. What is the impact? What is the loss you are going to have if this room catches fire? How do you calculate that?
sure. There could be like some scenarios. Means if uh, the fire can be extinguished like within few minutes or sometimes of its initiating in a house,
No
means
measure,
then there could be like
no measures taken,
yeah,
no measures taken. What is the worst case
no
scenario?
measures taken that can burn down the whole house. So
Okay,
yeah, that would be like
let us restrict
say
ourselves to
$1 million.
the room. Let us assume there is no house around it. There's just a room. So at least I have to calculate the worth of each and every item in this room. Do you think so?
Exactly, sir.
And I'll sum it all up. So what is your general estimate? How much is the equipment lying around you? How much does it cost? How much is the money invested in this room?
Maybe a few thousand, $20,000, say.
Okay, so fairly good amount. So $20,000, and maybe I have gone down to the market. Even this is just a guess. And if I ask you to be accurate, probably you will find the cost, how much this chair I have bought it for this much money, and now the salvage value of this chair, or the current value of this chair is this much, and so on and so forth. So to be very exact, if you can somehow estimate, and you can come up with maybe a figure like $25,232, right? So yes, we can do that, but doing that will cost um, a lot of money, a lot of time, a lot of investment. So to be more precise, to be more accurate about a risk, probably there is so prohibitive a cost that I would rather not go for that kind of calculations. Although I still desire that if I had those figures, that would have been the best scenario for me, because then I am the at least nearest to the truth. I would exactly know how much damage I will have, and naturally, when I am creating some kind of response, I can even say that how much damage I have reduced, how much I have secured or saved. Okay, are you with me on that?
Yes, sir.
So that means we do want to be accurate in quantitative. We do want to go into the details of each and every risk, but is it really useful? The amount of money and investment or effort going into finding so many details about each one of those risks might be prohibitive, and therefore that will take a lot of time. Secondly, uh, is it not diverting me from my basic purpose? I can achieve almost the same or at least a little less better results by making a very good guess. Like you said, $20,000. Similarly, if you can intelligently, try to calculate uh, using your common sense, you can say, okay, the probability of this room catching fire is say 0.1%, right? So 0.1% into 20,000 will be how much? 1,000?
200.
2,000? 200? 2,000? Two, two,
200,
two,
sir.
$200, right? So $200 in is the total effect of the risk. So what if I had been more accurate? The calculation would have been something like $257. So that doesn't really matter much. So this is a fairly good guess which I could make. We don't want to do more than that. But I am not making it a rule. I am not saying that we will have to do this type of work on all the projects. Maybe we are working on a very sensitive project, like there is a nuclear project we are doing, and probably each and everything is of much more importance, and every risk has to be calculated down to the nuts and bolts. So I'm not restricting this for that. But yes, of course, if I have a fairly good understanding about all the risks which have been shortlisted, then I can have a fairly good estimate created out of the sum of all the risks which are positive as well as negative. So overall risk is simple. It could be a cumulative effect of all the positive and negative risks on the project without consideration of when that risk occurs, just assuming that every risk we have thought of will occur during the life of the project. So, what will happen? What will be the overall impact of the risk? So, we add up everything, and whatever comes out is our overall impact. Now, look at it from another angle. What what is the capacity of the risk or risk threshold of the whole risk of the whole project? From the cost point of view, from the time point of view, from the scope and quality point of view, are we within the limits? This much money, this much time, are we within the limits from the overall perspective of the project? Maybe we are far beyond, we have crossed all the limits, and therefore we are in a very dangerous zone. Although we do understand that all of the risks are not going to occur, but still, when I am calculating the overall risk, I have to consider all the risks. So, what will happen ultimately? Number one, as I said, all the risks are not going to occur. Number two, we may have underestimated the impact of the overall exposure of the risks, because some risks, if they occur concurrently, they may be causing havoc to your project. That is unimaginable, because cumulative effect of two such you know chemical kind of risks are that they will react in such a way that it will go beyond the perception you can have. So in that case, we are still not having the full picture, right? And I am assuming it from the point of view when we have got many risks. Maybe initial risks we have identified were 1,000, and now I have got 200 risks in a short list. Now, out of these 200 risks, um, they are not very few. This is still a huge number. And out of this huge number of 200 risks, what can happen simultaneously? How can it impact me? How much the overall risk could be? This is very difficult to calculate. So somehow you have to come up with these figures. and keeping in view all the positive and negative impacts, like I have exposed to you both of the sides, all the risks are not going to occur simultaneously. Still, we are considering all, we are overestimating. And at this other hand, we are also underestimating from the perspective of we don't know what is the cumulative effect of certain risks, which could be much more than what we thought. So both ways, I am making adjustments. Ultimately, I have got a value which exceeds my overall risk, right? From the cost, time, scope, or quality point of view. At those points where it is exceeding, say it is only exceeding from the schedule point of view, so it is exceeding by 10 days. So what I need to do, I need to reduce it back by 10 days. And to do that, I have to look at those risks which are causing maximum damage to time. And I will try to select those risks for developing the risk response. So I am going to do it intelligently. I am not going to respond to each and every risk which has been shortlisted. I would respond to that risk which is going to benefit me in the form of reduction in overall risk or the cumulative risk at any one point in time. I'll talk about the cumulative risk later, but at least I hope you understand my point from the perspective of overall risk. If overall risk is to be reduced by 10 days or maybe $10,000, then probably I will try to attack those risks which are causing this maximum of this damage. The biggest risk which is contributing this towards this $10,000. Maybe there is one risk which is worth $6,000. So I will try to hit that risk and cut it short. I will try to respond that. And also remember, once we are going to be responding to the risk, that does not mean the risk which is being responded to is completely eliminated. It is brought down. Most of the cases we cannot completely eliminate any risk at all. So we may halve it, we may bring it to the 1/4 status or whatever, but we cannot completely eliminate a risk. So our try always is to bring that risk within the risk threshold of that risk. So far, so good. You know.
Yes, sir.
Sir, one question.
जी जी.
For calculating the overall risk. So we are here only talking about the quantitative risk, which we have quantified already.
Mm-hmm.
But what about the qualitative risk? There may be some different risk. We haven't have a numerical value of them, and what would be the expected monetary value if they occur. So means, are not they another risk to this overall risk? That means some of the risk from the qualitative risk will occur, and it will again spike up. Means are the money spent on the project or the risk reserve, the contingencies we have there.
Mohit, we must understand one thing, that qualitative risks were not any different from the quantitative risk. This is the same risk register. We identified all the risks together. There were 1,000 risks. Out of the 1,000 risks, I did the qualitative analysis and I sorted them out, and 200 risks were shortlisted to be considered for further analysis. Remember, 200 risks are shortlisted for further analysis. That means 800 risks have been dropped as not selected, right?
Okay, so they were not qualified to be in the risk list.
They are not to be considered, but I will leave out some amount of contingency to take care of those risks as well. Take care of them. The very simple rule is, maybe if it is a 20/80 rule we are following, then the 80% impact I have captured, 20% impact is with the risks which are not shortlisted, right? So For example, if for treating these 80% risks, I need, uh, for that matter, 80,000 rupees. If I need 80,000 rupees to treat these 800, these 200 risks, then that means if I, how much do I need to keep in contingency? If 80,000 rupees I need for these 80% risk, then how much should I keep for 20%? Naturally, that would be 20,000. Are you with me? Is it all right? Jinam.
Yes, sir. Yes, sir.
Okay. So 20,000 I have kept in the contingency, and if any of those 800 risks do occur, and many of them will occur, if they do occur, they will be treated out of that. Fine. So you are protected now.
Yes, sir.
You are now protected. So there is no problem at all. Right. Now let us only talk about the quantitative risks. These 200 risks can behave in different manners. First of all, apparently what I can see is that these 200 risks will all occur. This is one possibility. All of these risks will occur in different points in life of the project. So if I do nothing, how much will be the damage? So whatever is the cumulative effect of all the risks is my overall risk, right? Now I have to see this overall risk. How bad is it? Is how much is it out of the range I had specified from the perspective of time or cost or scope or quality, and as much it is beyond the limit, outside of the threshold, that much I need to treat. So as I was giving you the example, if I have to treat it for $10,000, then I will naturally be looking for those those risks which were causing maximum damage in money, in cost. And the biggest damage one risk is causing, the biggest risk which is causing biggest damage is $6,000. So I it will be my first priority to respond to that risk and somehow try to eliminate it. But naturally, probably I cannot eliminate it completely. So that $6,000 risk, if I can reduce it to $50, that would be wonderful. So I still need to reduce further, which is the next biggest risk in cost. I will treat that. So rather than treating all the 200 risks, I would go by this approach, that I will be treating those risks which are of most danger to my project. I hope you get this point.
Yes, sir. We will prioritize the risk.
Yes, exactly. It is already prioritized. Risks are already prioritized, but I am choosing the risk from the perspective of the overall risk. So before I can do anything, I must calculate the overall risk. So that is one perspective, that calculate the overall risk and then select which risks are to be operated upon. And the second thing was, which are the risks which, if occur simultaneously, can cause synergetic damage. Which synergetic means it would not be 1 plus 1 2. It would be something like 1 plus 1 11. So if these two chemicals are mixed, they can have a bigger blast. So if these two risks occur simultaneously, the damage will be multiplied. It would it would be much more. So such bad mixtures I have to avoid. So I will try to find which are the overlaps in the risks during the life of my project. Which of the risks are overlapping? So the overlapping period between two dangerous risks, can I would know how much is the risk at that point in time. How do I calculate how much is the risk on that point in time? Let me give you an example. Okay, just look at it to draw something. For example, this is the time on my project, and this is my project life cycle, right? It is not the S curve. This is my project life cycle, and this is how I am spending money on my project. This is from the cost point of view. Okay, so there is a risk in the life of the project happening here. There is a risk 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 happening here. Every risk has its own life. The peak point of the risk is when it is most likely to occur, and it has started. The probability of that risk has started maybe 2 days ago, and it will continue for another 1 day or something like that. So if I want to find what is the risk at any one point in time, for example, this is the time when I want to find how much is the risk at this point in time, then you see this risk has got this much impact, this risk has the maximum impact, and this risk has this much impact. So I will add all these three values from risk 1, risk 2, and risk 3, and that will give me the overall total impact of all the risks at this point in the life of the project. Got it? So I am not talking about the overall risk of the project. I am talking about the risk at this point in time. What is the total risk at this point in time? So if that point in time is not able to bear that much of risk, that much of load, then this load has to be reduced. And in this, risk 3 is probably the biggest candidate which could be removed, which could be reduced. And ultimately, because risk 1 and 3 are not having much of effect at this time, the maximum effect of risk 3. So probably I can select risk 3 for reduction, right? Ji Mohit,
Right, sir.
are you getting the
Understood.
जी सर बिल्कुल
okay, right? If you understand this point, then probably we can move ahead. And
श्योर
right, let me formally start it now. I don't think Shahid Saab has come. Okay, let us see what are the objectives for that. We need to understand the process of in-depth analysis or quantitative risk analysis of only those risks shortlisted from earlier process. Perform quantitative risk analysis using various tools and techniques, and then documenting the results. So we will be discussing the purpose and objective of this. Critical success factors, naturally, as we have discussed in the previous two, tools and techniques, and documenting the results. So the purpose first. Perform quantitative risk analysis process provides a numerical estimate of the overall effect of risk on the objectives of the project based on current plans and information when considering risks simultaneously. I think this describes what I have just told you. So we need to look at both the things: overall effect of the risk on the objectives of the project, as well as simultaneous impact on any point. Results from this type of analysis can be used to evaluate the likelihood of success in achieving project objectives and to estimate contingency reserves. So based on that, we are going to allocate the contingency reserves to that, usually for time and cost that are appropriate to both the risk and the risk response of project stakeholders. So talking about the numerical estimates, perform quantitative risk analysis process provides a numerical estimate. This I've already covered, I think. Yeah. It is generally accepted that analyzing uncertainty in the project using quantitative techniques such as Monte Carlo analysis, Monte Carlo simulations may provide more realism in the estimate of the overall project cost or schedule than a non-probabilistic approach, which assumes that the activity durations or line item cost estimates are deterministic. Remember, we did use the shortlisted risks to determine the overall risk of the project, but that can never give us the true picture. You're already, the point you brought up, that those risks which we have not shortlisted may also impact, and I have already kept some reserves for them, but at the same time, I cannot forget that anything can happen to me, and still there are some unknown unknowns which I could never ever recognize till now. Therefore, I must make room for them, and that is exactly why I need to look at the project from a very different dimension, and that is I should do some kind of simulations on this risk to understand what all can happen to the project and how much could be the damage. So Monte Carlo simulations is one of the tools for assessing that. So how does Monte Carlo work? Basically, this works based on I hope you understand that 3-point estimate. You remember 3-point estimate? Give now.
Yes,
Yes,
sir.
sir.
Okay.
The optimistic, most likely, and the pessimistic
Exactly. So what
sums
did we
up
do
all
with that?
together.
What was the benefit of that?
So that provide us a value which is closer
Okay.
to the mean value, because the most likely is weighted. It is the weighted average of the optimistic, most likely, and pessimistic estimates. So there is a weight assigned to the most likely value. So then that is closer to the mean.
Okay. But tell me, from where have these values come? These three values, from where have they come?
So this is from the simulation. Like means what could be the best case scenario, worst case scenario, or the most likely scenario. So means simulation can be done through some software, maybe through some expert judgment from some past data.
Exactly.
So
So data is more appropriate. This simulation cannot be done without the data. So from where is the data coming? Basically, when where do we use this 3-point estimate? You use it in estimation, right?
yes,
3-point
sir.
estimate we are using in estimation. Why are we using it? Because the deterministic estimates we use usually are very dangerous, because I say this job can be done in 3 days, and what if it cannot be done in 3 days? Whole of my estimate will go for a 6. So I cannot rely on a deterministic estimate, because that probably is not going to be the reality. In most of the cases, exactly that will not happen. Although, for just calculation purposes, for just satisfying your uh, inner self, you can have, well, I have calculated everything. That is okay with you. But actually, you don't know how much really this activity will take. So again, get back to the source and ask them what can be the worst case scenario, what could be the best case scenario. Naturally, any one person cannot tell you that. You probably have to collect this data from hundreds of people who have done this job, this type of activity before, and don't ask them the worst case or best case. Just ask them how much this activity will is going to take. So some people will say 2 days, 3 days, 7 days, 5 days, 6 days. So you will have a huge data. This huge data is then used in a probabilistic analysis in which we have most of the data in generally same bracket. If we ask a question from many people, probability tells us that most of the people will be of the similar opinion. This is what probability says. If I ask a question from many people, most of the people will be having a similar opinion. I'm not saying the same opinion, but the similar opinion. So, if I ask them how much time this activity will take, then maybe most of the people are saying 2 days, 3 days, 4 days. So, most of the answers I'm getting, the most frequent responses are 2, 3, 4. But I must cater for a pessimistic and an optimistic view. What is the worst case scenario? Is there anyone with a highest figure and a lowest figure? So, those two impossibilities or outliers, you can say, can also be considered. So the worst case scenario is this activity will take 10 days, and the best case scenario is, or the optimistic view is, uh, it takes 1 day. So the most likely is, say, it was 2, 3, 4, so I take 3 days. So I have a pessimistic view of 10 days, an optimistic view of 1 day, and a most likely view of 3 days. This is how this data is generated. This is not generated automatically. Well, we can generate this data automatically, but that would be the worst example. You should at least do some work in the field. Some data must be collected from the field. Do not leave everything to the computers. So computers are not intelligent enough. So this data is actually sought from the source, from the stakeholders, from the people who have experience in doing that kind of job. So again, I would say this is a very difficult effort to collect this kind of data when you are collecting the estimates. But if you have time and you can, find certain tools which can do it uh, quickly, then probably we can do that. Don't go for an interview and long discussions. Just ask them what is your best guess this work can be done in. So everybody will give their own, best guess, and that could be used for our probabilistic estimations. So now I have got three things. Um, Most of the people are of the opinion that this job can be done in 3 days, and these most of the people are the majority of the people, right? So, and there is an outlier who says, no, I have personal experience that this job cannot be done less than 10 days. You go to that person and if you ask him, why do you say so? Why this cannot be done less than 10 days? Then he would say, well, I have personally done it. And when I did it, this went wrong, that went wrong, and this happened and that happened. And ultimately, we ended up doing uh, it in 10 days. And we couldn't do it earlier. You see, this person is not lying. This person is correct in whatever he is saying. And he is a person who has faced all the negative risks. Unfortunately, he was hit the worst with all the negative risks. If I go to the person who is saying only 1 day, then we will find out that he was so lucky that he was hit by all the positive risks. And the job which otherwise takes about 3 days, he could do it in 1 day. I cannot ignore the optimist or the pessimist. Both of these people are very important to me because I could be one of them. I could be facing all the bad risks or all the good risks. So my estimate of 3 days may not work, and therefore I am going to use this 3-point estimate. So the immediate use of 3-point estimate is that we have calculated an estimated duration for that activity by the formula, optimistic plus 4 times the most likely plus pessimistic divided by 6. And if you have not done that, you also can calculate the standard deviation out of it. Can someone tell me how can you calculate the standard deviation out of it? जी जनाब.
Pessimistic minus optimistic divided by 6.
Divided by 6. Are you with me, Shahid Saab? You're welcome. Have you the answer for this?
Yes, sir, I'm with you. No, sir, I don't have an answer.
Okay, that is simply, as Khayyam has said, the two extreme values, the pessimist value and the optimist value, find the difference between the two. So this is the margin between the two extremes, and we divide it in 6 parts because most likely had majority, so we give 4 parts weightage to the majority, 1 part weightage to the optimist, and 1 part weightage to the pessimist. So it comes out to be 6 parts. So I divide it into 6 parts. Between the pessimist and optimist, the distance is 10 minus 1, 9 days. So 9 days, if I divide by 6, my standard deviation would be 1.5. Not the standard deviation, I would call it a deviation. My deviation would be 1.5. That means, okay, what is the estimated time? 1 plus 3 into 4 plus 10 divided by 6. जी क्या हुआ? 3.8 or something.
So
Yeah, I'm sorry, the mics were off. You say again?
1 plus 3 into 4 divided by 6, right?
No, 3 into 4 plus 10. The optimist plus 4 times the most likely plus pessimist also.
Yes, sir. The answer is 3.8.
3.8.
3.83
Okay,
to be exact.
3.83. So now I know that otherwise I would have taken 3 days as an estimate for this activity, but if I use 3-point estimate, there is an automatically built margin of 0.383 into it. So I will take 3.83 days, and if somehow you want to round it, it becomes 4 days. So automatic protection will be built into it. You see, when the activity which I was considering it to be for 3 days, it might be placed as 4 days now, or if I take the exact value 3.83 days now. So you can see the risk has been considered, and the estimated duration does have a margin built into it. This is in addition to all the contingencies and reserves, we are building this much protection into the duration estimates and cost estimates. Are you with me on that?
Yes, sir.
Yes, sir.
Okay. If that is true, then what is this deviation meant for? 1.5 days deviation, what does it mean? Can someone explain it to me? What will this deviation do to me?
So there is one standard deviation, that is the incremental time for uh, that task to factor the delay into it.
Mm-hmm. Good.
Like,
Good.
like, yeah.
Okay. Shahid Sahab, can you put in something? जी, any input from खयाम आपकी तरफ से?
Sir, I agree with Mohit. ये जो standard deviation है, basically तो it tells you okay, how far the reading is from the mean. So
Okay.
जितनी standard deviation ज़्यादा होगी, obviously इतना फिर risk ज़्यादा होगा, uncertainty ज़्यादा होगी.
लेकिन can you ascertain how late can I do the project and how soon can I do this project or this activity for that matter? How late or how soon? So 1.5 tells me that one deviation size is approximately 1.5 because 1.5 is a state calculation. It has to be, going through some other details of probability and turned into the standard deviation. But just for state calculation, I would say if this is the center, 3.83 is the center, then I can move ahead by 3 deviations or move backwards by 3 deviations, and the size of my one deviation is 1.5. So how much can I delay this activity if I use one deviation plus? That means 3.83 was the duration estimate, and if it is delayed by one deviation, a 1.5 will be added to it. So how much it comes out to be? 5.33. So I will be comfortable if this activity is delayed and it takes 5.33 days. The danger has increased, but I am comfortable that yes, this could have happened. When I was taking just 3 days duration, I did not have any understanding of the risk, how much risk this activity is carrying, how much early it can be done, how much later it can be done, how can I control the damage caused by this activity. As soon as this activity was not done in 3 days, I am in panic because then I have to change everything. But if I am using 3-point estimate, I can be very comfortable. I can say, okay, if this activity has delayed from 3.83 and it has taken 4 days, then probably we are already in our first deviation, and our first deviation can drag us as far as 5.33 days. So we will try to do the damage control and not let it go beyond 5.33 and contain the risk within one deviation. But although the second deviation is more risky, but even if I enter into the next deviation, the second deviation, it still can probably be controlled. Although some money will be lost, some time will be lost, we will have damage. It is not free of cost, but still it is doable. It can be contained. But anything beyond third deviation is impossible. As soon as your boss drags you to the limit of the third deviation or even to the second deviation, you must put your foot down. This cannot be done. And if he is not convinced, you can show him the probability diagrams and show him why is it not possible. So this can be proven through probability that this this activity cannot be done beyond beyond this duration and below this. I am using it if an activity is delayed, how much it can be delayed by one deviation, two deviation, three deviation is the limit. How early this activity can be done. We can bring it back. Your boss is forcing you to do this activity earlier. So how early can you do it? So one deviation back means 3.83 minus 1.5. So approximately this much is fine with me. I can somehow try to compress my schedule to bring it back to that level. Okay, so this is about one activity. What about the whole project? Have you ever heard that you can calculate the risk of the whole project? This is just one activity, and every activity has this kind of 3-point estimate. But because every activity has this type of 3-point estimate, probably if I can somehow convert this thing to the project level, I can somehow calculate the overall pessimistic and optimistic dimensions of the project. I can quite sensibly guess how much this project is going to take. Are you with me?
Yes, sir.
Yes, sir.
If it is becoming more difficult, please tell me.
Yes, sir.
If it is becoming difficult, tell me. I will stop and I'll explain again. I know I am getting into uncharted territory, which you might not have studied before. You might have studied a 3-point estimate, but one thing you have never studied is how 3-point estimate can be converted or can be expanded to the whole project. Have you done that?
No, sir.
Okay. Let me take a small little example and show it to you. Okay, let us assume that we have these activities. Maybe this is a very small little project. And the three values for A is 1, 3, and 10, 2, 6, and 8, 5, 6, and 8, and 4, 4, and 5. Do you get this? The extreme left is the optimistic value, the minimum time. Extreme right is the pessimistic value, 10, and the middle value is the most likely. So first calculate
Yes, sir.
the value of estimated time for each one of them and the value of S for each one of them. You tell me. So the A was 3.83
3.8, sir. Yes, sir.
and deviation was 1.5. What about B?
2
6 into
plus
4?
24
24, 34, 34 by 6.
divided by,
6 point something.
sir, 5.6.
5.6.
Sir, 2, 6, and 8.
2, 6, and 8, yeah. 24, 34,
That's
34,
2 plus.
5.6. And what is the deviation? 8 minus 2? 6
One.
deviation is 1.
6.
Division is 1. In this case, see, 5 into 6 into 4 plus 8.
5 plus 24.
37 by 6?
Sir, 6.1.
6.1 and uh,
0.5, sir.
0.5?
Yes, sir.
Right. About D?
No,
So that is 4.1.
4.1
The
and
PERT estimate is 4.1. Yeah.
4.1 and deviation is 1 by 6. Comes out to be 0.15.
So 0.16.
16. Okay. So we are all okay with this? Let us do
Yes, sir.
the network analysis here. So if we early start of this activity is 0, then here will be 3.83. Early start is 0. Here will be 6.1. 6.1 plus 4.1 is 10.2. And 3.83 and 6.1, this B activity will start on 6.1. 6.1 plus 5.6, 11.7. Am I okay with it? The project takes 11.7 days, right?
Yes, sir.
Okay. We are able to calculate the estimated time for the whole project to be 11.7. Can we calculate the deviation for the whole project? That is
So
the
is it
thing.
going to be the sum of standard deviation of all the activities combined into the
It
whole
cannot be
project
done like that.
estimate?
It cannot be done like that.
So just throwing an idea. Yeah.
This is the problem with it. The deviations cannot be added like that. You see, that impact of the deviation of activity A would be, you know, aggregated onto B in a very different way. And just to tell you an example, do you remember how did you calculate this right angle triangle? How do you calculate the value of C?
So hypotenuse square is equal to perpendicular
C
square
is
plus base square.
C is
Pythagoras
equal to
theorem.
under root A square plus B square. Isn't it? क्यों जी?
Yes, sir.
Yes, sir.
So actually this is like that. These deviations are like vectors and they have different directions. So you just can't add them. To add them, you have to uh, convert the impact so far into the next way. So we will see what is the impact in the beginning. What is the deviation in the beginning? Zero deviation. So in the case of A, the first deviation is 0. And what is the deviation now? Or if I am calculating A, what is the deviation of A?
So 1.5, sir.
So just let's make it 0 point A. This is point B. This is point C, and this is point D. So what is the deviation at the end of point A? That would be 0 square plus 1.5 square whole under root. Got it?
Yes, sir.
Okay. So in this case it is easy because A is 0 and B is 1.5, then 0 square plus 1.5 square under root, it comes out to be 1.5, right? So this is deviation till this point, right? What is deviation till this point? That is 0 plus 0.5, this is 0.5 square. Okay, which is the higher deviation out of the two affecting B? As far as deviation is concerned, 1.5 is a higher deviation, right? So to calculate
Yes,
the
sir.
deviation at point B, it would be 1.5 square plus 1 square whole under root. This will give me the deviation after point B. What does it come out to be?
25 plus.
No. It is 1.5 square plus 1 square. It's not 25.
So 1.5 square is 2.25.
2.25 plus
Plus
1, 3.25 under root. What is it?
So this is 1.80.
So 1.80. This is the deviation at point B. You will observe that deviation will increase. Previously it was 0, then it is 1.5, then it is 1.8. This is cumulative. This is being cumulative. Now let us see what deviation reaches at point D. So deviation till C was 0.5 and the deviation in D, the D activity deviation is 0.16. So it will be 0.5 square plus 0.16 square whole under root. So 0.5 square plus 0.16 square whole under root. What is the deviation?
0.25. So this is 0.275.
So at D point it is 0.275. So this is the deviation from D. So if I travel from C to D, the deviation is 0.275. If I travel from A to B, the deviation is 1.8. So which is the higher value reaching the end point?
So 1.8.
So 1.8 is my project deviation and 11.7 is my project duration. What does that mean? Uh, can I clear it off? Just remember 11.7 and 1.8. 11.7 and 1.8. So in my probabilistic estimate of the whole project, this point is 11.7 and size of my one deviation is, what was it, 1.8?
8. Yes, sir.
Right. Okay, let us add 1.8 to 11.7.
So 13.5.
So this point is 13.5. Another 1.8,
15.3.
15. Another 1.3, 1.8,
17.1.
17.1. Okay, minus 11.7 minus 1.8.
9.9.
Minus 1.8,
8.1.
minus 1.8.
6.3.
6.3. Yeah.
So just imagine what we have done with this project. Now we can clearly see that this project, in the most opportune events, forget about all the risks you have identified, unknown or known or whatever. This is I have mathematically simulated the whole project. This project of 11.7 days can earliest be done in 6.3 days and no less than that. It is impossible to do it less than 6.3 days. and maximum it can take is 17.1, and there is no possibility of doing it beyond 17.1. But my deviations are, if it could not be done in 11.7 days, it can be delayed for one deviation to 13.5. Two deviations, I will resist less in one deviation, I will resist more in second deviation, and I will resist most in the third deviation, because beyond third deviation is impossibility. So one deviation plus and minus is called 1 sigma. Two deviations plus and minus is called 2 sigma. And three deviations plus and minus is called 3 sigma. Right? And you might have heard about 6 sigma.
Yes, sir.
What do you imagine that 6 sigma would look like?
Sir, would be the 6 values on each side of the mean.
Exactly. So these tails will be extended. These tails will be extended, and then we'll be having 4, 5, and 6, and that would add accuracy. But for the time being, as far as project management and normal probability is concerned, we can restrict ourselves to 3 sigma, because 3 sigma can give us fairly good probabilistic results. As far as the duration of the project is concerned, this is the best possible estimate which could be calculated. But this is even still not better than what Monte Carlo can do. You just imagine that what I have done in front of your eyes is a kind of a simulation of Monte Carlo manually. But Monte Carlo can do even better than that. And let us see what Monte Carlo can do. Now you understand how the things happen, right? And now you
Yes,
know
sir.
what is the flexibility in the project. But if you are using deterministic estimates, you have no flexibility whatsoever. If your project is delayed, you are in a shock. You don't know how to fix it. If your project is being compressed, somebody is forcing you to do it early. You don't have a you don't have a reason. Why are you resisting, and how much should you resist? So I have told you, you should resist not beyond 6.3, and you should not get delayed beyond 17.1. Understand my point?
Yes, sir.
So this is how it is. Now, let us talk about Monte Carlo analysis. What happens in Monte Carlo analysis is that because it is humanly not possible to calculate all possibilities, what I have calculated in front of you, this is one of the probabilities. This is a fairly good way of doing it. But even the better way would be running this project hundreds and thousands of times manually or on paper, test on dry running this project several times with different data. You understand my point? And that different data would be coming from our 3-point estimate. A activity was 1, 3, and 10. So I tell Monte Carlo to do a dry run. It randomly picks a value for activity A. It says, okay, 1. For B, it picks out of the three values, it picks any one random value. For C, it picks any one random value. For D, it picks any one random value, and ultimately solves this network diagram and finds out that the duration could be, say, 10 days. Then I ask it to run it again, and this time the values are again changed, and this time it will be, say, 15 days. Next time it would be 7 days. So you mean you keep running it hundreds and thousands of times, especially when you have more activities, you have more chances of running possibilities. You have more possibilities. Here you may have limited possibilities. Maybe within 100 possibilities, you can run out of all the cases. But if you have got hundreds of activities, then probably there could be millions of chances, millions of iterations could be run dry. But naturally, we don't want to run millions of iterations. If I can run a reasonable number of iterations on any project, that will provide me a fairly good TE value and the deviations. Let us see what happens. I need to tell you another very important thing. Um, while doing the probabilistic analysis, would you be satisfied with the as high the value, more is the accuracy, or you want to stop somewhere? Number of runs should be how much?
Um, so that would that not depend on the OPS?
Forget about it, OPS. In probability, there are no OPS. Probability means wild run. Okay, let me give you an example. Um, we were in Nadra, and in Nadra, we were having a data of 65 million applicants from all over the Pakistan. That was the census report. The census was done, and as a result of census, we had the data of 65 million people. Got it? I thought
Yes, sir.
in those days, what I assumed, I guessed, was that this is a huge quantity of data, and if we can digitize all this data and then run probabilities on it, and we can find a lot of hidden information, right? Is it what your mind says?
Yes, sir.
Yes, sir.
Okay. So when we did that, I had to hire a number of statisticians for manipulating the data. We had created a complete data warehouse, and I hired about two or three statisticians who were reporting to me, and we used to get very interesting results coming out of it. That is where I first time learned that just by having a huge quantity of data does not improve results. Yes, if I have got very less data, that will affect. If I have got only data from two people or three people, that is that will not facilitate the probability. It is not possible. I can't have a beta distribution. In case of there are only three values, I will have a triangular distribution. I don't have any curves in it. But if I've got more people, the curves start forming. These curves start forming. And more the data, more curvy is my distribution, right? More curvy means that, uh, what should I say? My uh, the number of people, opinion of people is increasing, and that is adding to the value of authenticity of my data. But as say it reaches a number of 100, 200, 300, this is the optimum result I can get. From 0 to 100, I got a wonderful result at say 100 or 200 or 300. But if I take the data of 3 million, that would not be much different than the data which the result which I got at 300. Meaning what? The
Sir, wouldn't there be more variation in the data? Because, like, means as you have mentioned the Nadra database example, so means
Mm,
people are there from the different walks of life.
mm,
So this would be a broader spread, means, and it would
much broader.
form like a nice Gaussian curve. So
Yeah,
wouldn't
but
it be better to have like
the question is how nice do you want it to be? How fine do you want it to be? it is not going to change its shape. Once it takes its shape, once this curve has established, then it will not improve any further. A little bit improvement is there, but it is not going to improve any further. Once the beta curve has been established, then fine tuning might be done, but the ultimate result is not that unique. But the uniqueness lies in very less data to 100 data. You will give great results as you start increasing the data, and as soon as you reach 100, you will get an appropriate kind of a curve. You increase your data to 200 or 300, you will still see some betterment in the curve, but that would not be as much as you had seen in first 100. So maybe the improvement you have seen is in 10 units was equal to the 200 units. And then later on, even if the data is further increased, that might be equal to 1 unit of the first 100. That means it has attained its critical mass, and by increasing the data, it doesn't increase the authenticity of the data. The probability remains almost the same. Therefore, there is no fun in having so huge data. That's exactly why when you are doing data collection for surveys, they say that you must select your sample size. I cannot collect data from all the Pakistanis. So what I do is I collect the data from all types of segments. So I go to each segment and maybe I get one data form filled from that segment, from one person of that segment. That way I will have the diversity of whole of the country, and that diversity, if put together into a beta curve, that will give me a fairly good guess. Are you with
सर
me?
इसमें we know कि Monte Carlo analysis not only requires a specialized software, but it also needs someone who can actually then interpret the results as well. So
Well, that is not that difficult. That is
it
not
would
that
also make
difficult.
sense to not run it too many times.
Exactly. Do not run it too many times. Um,
Yeah.
when you install that Monte Carlo software, that will ask you how many times do you want to run the simulations, and it advises you also that maybe 300 is a good figure, or 500, 100, 200, 300. So generally 300 is a very good figure, but if you want to take 500, that is okay. But remember, it is not going to be, the results are not going to be much difference. Even if you take 1 million round, that will take a lot of time, but it will give you almost the same result. Therefore, just take 300 or 500 if you want to be safe, right?
Understood.
So that will give you an appropriate result. Now, after having run that, it will give you the result in a very beautiful way. It will show you this kind of a graph which I have just made. It will show you that the optimum chances of completing this project is in this many days. Say 11.7, maybe that figure is going to be even better than this, because my figure is calculated manually, and it is not calculated based on hundreds of rotations of simulation. So my figure is very bad. So that could be, say, 15, and the standard deviation size would also be different there, and that is the most authentic data. Now it tells you that you have a probability of finishing this project you have a high probability, or you say maybe 100% probability of completing this project in 15 days. But what you have what you have planned, your TE was 11.7. So you say, no, my project was to be done in 11.7 days. That's what it is. So your project was 11.7 days. He is saying it will take 15 days. Now, uh, how much effort you should put in, and if you try to reduce the project duration from 15 to 11.1, how much is the percentage of probability that you will be able to do it in that time, that much time? So computer will tell you to do this project in 11.7 days. The possibility is just 70%. That means you carry 30% risk in completing the project earlier than 15 days. Are you following me?
Absolutely, sir.
Okay, here I would like to advise you that you should download a software. Its name is Risky Project. Risky
So
Project.
Palisade का भी है. I think
Palisade,
I've used Palisade.
that is at risk, at risk.
Yes, sir.
That one is at risk. Let me write it down here.
Yes.
But that is a very expensive software, and that is a very heavy duty software. That one is,
Yes, sir. I used the trial version. वो 15 day का जो trial version लेते हैं, I've used that.
yeah, that is very expensive. A normal man cannot. It is just like buying Primavera. So as you compare
Yes.
Primavera with MS Project, exactly, you compare at risk with Risky Project. There are many software, by the way, but naturally, at the top of the line is at risk. But at risk, as I said, is very good. It has got a lot many things, and maybe it solves all your problems. But the one I am advising you is Risky
Risky project.
Project, and the website is riskyproject.com. Right, riskyproject.com. The interesting thing about this software is that you can download it as a student. It is so lightweight. It is so lightweight that it will just take a very small space in your computer, and it will hook into your MS project, it will hook into your Microsoft Word and Excel and wherever you want. So you can transfer data from anywhere to anywhere. You create an Excel list and you press risky project, and it all goes there. You have data in your MS project, and that goes to risky project. So you can always shift any data from anywhere for the analysis purposes. And Risky Project is not only so lightweight software, but it is a full-fledged scheduling software. If you don't want to use MS Project, you can do everything what MS Project does on Risky Project. You can do activities and everything. You network analysis. You can do everything there. But naturally, this is a software for risk management, and for risk management, it will give you many options, many analysis. You can do sensitivity analysis, you can do this Monte Carlo analysis, and I think more than 10 different analysis, risk analysis you can do. And when you ask it to do the Monte Carlo analysis, and you give it, say, 300 or 500 cycles, simulations to run, you know how much time it does take? Hardly a minute. In hardly a minute, you will get the data. I cannot assure you about at risk. How much time does it take? You
So
have
it
experience,
also takes about time.
right? But
You can run that.
at risk is a very heavy duty software, right?
Yes, sir.
It takes a lot of space on your computer and in your memory. But risky project is good from that aspect. And then once the result comes on screen, I don't know how at risk software shows the result. It shows it in form of beta curve,
Distribution.
bell curve, and on top of the bell
Yes, sir.
curve is a slide bar. And slide bar appears at, say, your duration was selected as 15 days, so 100% probability would be shown at 15 days, and you can slide the bar to 11.7, and it will keep decreasing your percentage. I hope you understand my point. So this is
Yes,
so
sir.
easy that everything is happening in real time in front of your eyes. What if I do this? What will be the result? If I do this, what will be the result? So you can do the whole analysis right in front of your eyes. Got it, Ji?
Absolutely, sir. Got it.
I don't know how much you have captured what I have said, but this is a very interesting thing, this Monte Carlo thing. And
So it was very interesting.
eh,
Mohit knows I'm terrible at mathematics, but वो जो हमने standard deviation वाला किया है आज, I really enjoyed it. उसको I grasped it as well.
okay, wonderful. That is great. I know it was very poorly written on the screen. First of all, my writing is not good. Secondly, it was difficult to write on the screen. But anyways, I tried my level best. But this is how the things are. So if you have got this understanding of Monte Carlo, then probably the things will become very simple for you. When you study this quantitative analysis, Monte Carlo you have already studied, by the way. This is what is called Monte Carlo analysis. The only thing I need to explain is sensitivity analysis. Okay, so let me get back to the slide.
Next job is the criticality analysis as well.
Which one?
Criticality analysis, sir.
What does that do?
So I think criticality analysis is used when we're doing scheduling risk analysis, or when we do it for cost, we do sensitivity analysis.
No, 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 no.
Hmm.
This is criticality analysis. Monte Carlo is your criticality analysis, and Monte
Okay,
Carlo can
wonderful.
be done on cost as well as on duration.
Yes, sir, I know that, but I thought criticality is different. But if it's the same, okay, wonderful.
Sensitivity can also be done on both.
Okay.
Sensitivity is for the purpose of seeing that which risks are affecting you at any one point in time
Hmm.
and prioritizing them, which risk to pick up. So the further prioritization thing is done in sensitivity. I'll tell you a story about sensitivity also. Um, okay, tell me, have you ever developed a computer program?
नहीं सर मेरी तो फील्ड ही नहीं है मोहित ने शायद किया
Ji Mohit,
Sir, yes, sir.
or how do you do it? You have got certain variables as input,
Then
some
you have
input
the
values.
requirements, the
So
functional description of the software.
I'm just talking about the calculation part of it. Say you have to do some calculation um, by picking in three values and getting one value as answer. A very simple example. So you input three values A, B, and C, and Z is your answer. And some processing goes on into the computer, which you have programmed into that thing. Got it?
Yes, sir.
Okay. Once you have coded this, have you ever dry run your code without running it on computer? Have you ever done the dry run?
Means outside of that computer, like
Like on paper?
simulating what would be the result.
No, no.
Yes, sir.
You have got you have the code written in front of you, and you are trying to uh, put in a value into it, and then try to guess what is going to be happening at this step, at this step, at this step, and ultimately guessing what is the output of it.
Yes, breaking down of the code. Yes,
Yes,
that
breaking down and
uh,
putting in different values,
breaking down of
putting in different values.
exactly, sir. Means that is like putting it into the state machines. That
Yeah, yeah,
means what would be the value on this step, on this step,
exactly,
this step.
exactly.
The breakdown of the
Right,
whole
right.
code. Yes.
So basically, you are doing the sensitivity analysis. You are trying to find these are also this is also kind of a simulation. This is sensitivity analysis. You are trying to find that what will happen if these values are put into this code. What will be the answer? The best way of doing it is that you out of the three values, you you keep one value constant and rather two values constant and put in only one value and see what is the impact on Z. If A and B are equal to 0 and C is from 1 to 10, so what is the value of Z, right?
Yes, sir.
Okay, once you do that, okay, let me show you. Okay, say this is X or Z and this is A. So what is the graph between X and A? For example, the relationship between A and X is like this. Relationship, if sorry, B and C are constant, A is related to X in this way. If A and C are constant, the relationship of B is like this. This is the line of B. This is the line of A comma B comma C. And for example, C line is like this. This is C. So I can draw these lines by keeping the other two constant. The relationship between the answer and the variable, one known variable, could be found like that. Then what will be the impact of all of the three variables could be calculated by calculating the area under curve. The area which is under curve of all of these three lines. All of these three lines are cutting here. Do you get this point?
Yes, sir.
So this is the maximum effect ABC can jointly have on X. If you did not understand this, I'll give you another example. Have you ever tried to open a number lock? Normal on
The
briefcases,
combination lock, sir.
combination lock. Have you ever tried to open it? How many options are there to open
Without knowing it, sir?
without knowing it?
Sir, there are the permutation and the combinations,
And how
like
many?
depending upon how many digits are there.
Three digits. How many options are there?
For n raised to power 3, so that would be
That would be Hayam.
so 999 would be the maximum figure, but there has to be the combinations.
999. All the combinations are covered. 999 plus 000 also. Okay?
Yes, sir, 1000.
1000 possibilities. Shahid Sahab, are you with me?
Yes,
Ji
sir,
channel.
man. Very well.
Acha. So you can see that we have got 1000 possibilities, and if you have to open this lock, you have to try it 1000 times. Can you do sensitivity analysis on that? Can you keep one value at 0 or two values at 0, B and C at 0, and just move A from 0 to 9? What will you find? What will you find? If you revolve only one digit from 0 to 9, can you find something?
Nothing, sir. In order to open that lock, all digits have to be in the correct order.
Right.
So moving on only one digit will not work. So
But one wheel has to do something with opening the lock. So one wheel will come to that point. There is one number out of these 10 numbers which is different than others. Do you get this point? So if you can
Yes.
Very carefully monitor the revolution of these 0 to 9. You will find the behavior of this clicking different at one point. This is how people open the number locks. So they actually do the sensitivity analysis. They first look at one option closely and see its behavior from 0 to 9, and wherever they find the behavior is different, they mark that number. Then they do the second number from 0 to 9, then third to 0 to 9, and ultimately they will try that specific number and lock will open. And
So with the behavior you are mentioning, the mechanical behavior of that lock?
yes, mechanical behavior, the rotation of the क्या कहते हैं, of the ring on its pivot. And if you want to be
Okay.
even more specific, take a small little light torch and look inside of the lock. You will see a bar holding these rings. That bar has got an indentation at one point on the lock. One point, there are three bars, interconnected bars. One is carrying A wheel, B wheel, and C wheel, right? Every one bar is carrying A, B, and C, and these bars are connected together. So every bar has its own rotation. So every bar will have a indentation on which, if the number comes, that is the right place. So if you can find that indentation, you can bring the lock on the right place. So find that indentation on all the three bars and align the number. That number will open the lock. If not, then reverse the number. For example, it is 1, 2, 3. Then add 5, 5, 5 to them. It will be reversed. The number will open. So in this class, you have
So
been
that's
taught
excellent
sensitivity
information,
analysis
sir.
in the way that you can open any lock now.
Sir, have you been working in any forensic department or some criminology or something? Like
I was
you're
part
so
of the
much
heat.
into it.
Okay, so this is sensitivity analysis, and in sensitivity analysis, we can do one more thing, and that is called the tornado diagram. Have you seen that?
Yes, sir.
Tornado diagram. So what we do is we align all our risks in such a way that no matter it is you see, the nature of a risk is like, I flip a coin, 50% chances of success and 50% chances of not succeeding, right? So let it be my neutral line and say this is my risk, 50% here and 50% here, 50% positive and 50% negative. So every risk has some positivity and some negativity. Naturally, all risks are not like 50-50. They are not all coins. Sometimes there are dices. Sometimes there are other options. So some risks will be like this, less positive and more negative. Some are like this, more positive and less negative. And there could be any shape. And there could be smaller risks, even smaller risks. So if you can plot all the risks, all the shortlisted risks on a bar in such a way that the biggest risk, no matter it is positive or negative, the biggest risks are on top, and then the smaller, and then the smaller, and then the smaller, then it will form a shape which is like a tornado. You see, it is a tornado diagram. Get it?
Yes, sir.
So I am just explaining everything from a layman's language I am not being very technical. I am not trying to uh, tell things which may not be understood because I have to explain everything verbally, and I don't want that you don't understand it. Anyways, ji, so in a way, I have explained to you Monte Carlo and sensitivity and tornado diagram and all that. So once they come, you will not be much shocked about it. So qualitative risk analysis may provide enough information for development of effective risk responses. You see, why are we doing all this? As if we can select the risks which have to be operated upon, and then we can effectively respond to the risk. We can anyways respond to the risk, but to be effective, you have to find which risks to be selected for operation. During the, especially for smaller projects, this becomes more important. During the planned risk management process, the benefits of quantitative risk analysis should be weighed against the effort required to ensure that the additional insight and value justify the additional effort. This is the point in favor of what I discussed earlier. If I want to find the details of one risk to surgically explore into the probability and exact damage, it may take a lot of time. Just weigh against the effort required to ensure that additional insight and value justify the additional effort. If it is just does not justify, do not waste your time. Do not go any further into that. Partial risk analysis, such as qualitative risk analysis, aim at prioritizing individual risks viewed one at a time, and therefore cannot produce measures of overall project risk when all risks are considered simultaneously. Calculating estimates of overall project risk is the focus of perform quantitative risk analysis process. Specific project risks are usually best understood and quantified at a detailed level, such as the line item cost or schedule activity list. By contrast, project objectives such as achievement of the project's budget or the schedule are specified at a higher level, often at the level of total project. An overall risk analysis, such as one that uses quantitative techniques, estimates the implication of all quantified risks on project objectives. So all the risks which have been shortlisted must be considered for that. Method implementation requires complete and accurate representation of the project objectives built up from individual project elements, project schedule and cost estimate, etc. Identifying risk on individual risk project elements such as schedule activities or line items. You see, the PERT data are 3-point estimate we have taken from the individual activities and we have converted into a Monte Carlo analysis, including generic risks that have broader effect than individual project elements, and applying quantitative methods like Monte Carlo and decision tree analysis that incorporates multiple risks simultaneously in determining overall impact on the overall project objective. Only one method which is left discussing is decision tree analysis, which I'll be discussing a bit later. Results will be compared to the project plan, baseline or current, to give management an estimate of the overall project risk and will answer important questions like what is the probability of meeting the project objectives, how much contingency reserves are required as far as the buffers and time, resources, cost are concerned, is needed to provide the organization with a level of certainty it requires based upon its risk tolerance. What are those parts of the project, such as line item cost or schedule activities, which contribute the most risk when all risks are considered simultaneously? Which individual risks contribute the most to overall project risk? This is exactly in line with what I have been talking about. So you have to find that risk which is contributing the most to overall project risk, and as if that can be selected for further response planning. Okay, I'll leave it today here. We will start with the stakeholder tolerance tomorrow. So if there are any questions, house is open. You can ask any questions. Ji Janab.
So the question is not related to the lecture. That was crystal clear to me, and today it was very interactive. So the question is that means, does the exam ask you to simulate this risks into the Monte Carlo techniques and the tornado diagrams we mentioned? So means
There might
any
be
exam expectation like that?
actually, it is not going to be a very difficult or lengthy question. If at all they refer to a Monte Carlo analysis, they will explore any one aspect of the Monte Carlo. Maybe how the data is put into it, what is the role of the 3-point estimate in the Monte Carlo analysis, or what is the result expectancy out of it, that kind of thing, which is conceptual in nature. They cannot ask you to calculate something on the basis of that.
Not the numerical calculations. Okay, sir.
Not much, which can easily be done on paper and pencil, only that much.
Okay, perfect, sir.
Okay, Shai Sahib, is it okay today? Ji Shai Sahib.
We woke Shahid Sahab up in the middle of the night.
Yeah. Okay, I think we should call it a day, and maybe we have only one more day to go in morning, because in morning time my throat is also not really working very properly. I feel about it, but you see, tomorrow is the last day. We will do it in morning, and then we'll get back to our routine of
Our previous schedule, sir.
yeah
Yeah.
9:30 to 11:30. So thank you very much for listening patiently to me, and take care. The office. See you tomorrow.
Thank you, sir. Allah Hafiz.
Thank you, sir. I love it.